Hello and welcome to this tutorial. From this tutorial we will do IMDb review classification with RNN and LSTM. Let us begin. First we have to do installation and setup. Pip install TensorFlow dash GPU execute. It will take some time to install TensorFlow GPU version. After installation, scroll down, import TensorFlow, import TensorFlow as TF, execute. Great. Now check the TensorFlow version, print TF dot version 2.0. So we have successfully installed and imported TensorFlow 2.0. Now import other important libraries. Import numpy as np. Then import pandas as pd. And at the end import matplotlib.pyplot as plt. Execute. Great. So we have completed installation and setup. Now we have to do data pre-processing. Step 2. Data pre-processing. First import the libraries. Importing the libraries from TensorFlow .keras datasets, import IMDb. After that import one more library from TensorFlow .keras .preprocessing .sequence. Import pad_sequences. Execute. So we are importing these two libraries here. First one is the IMDb. This is the dataset that we are importing. This is the built-in dataset TensorFlow.keras.datasets, and we are importing this class pad_sequences for data pre-processing. We can get this dataset on kaggle.com also. This one, IMDb movie reviews dataset. Scroll down. This dataset contains 50,000 reviews, 25,000 in training set and 25,000 in test set. Here we have to build a model to classify these reviews. Look here. If review is less than 5, then negative, and review is greater than 5, then it is positive. You can see all the details here. We are importing this dataset from built-in datasets in Keras, not from the kaggle.com. Now load the dataset. Loading the dataset. Create two tuples is equal to xtrain, ytrain, xtest, ytest. Now type name of the dataset, that is IMDb dot load_data. Here we have to enter one argument, this one, num_words. 20,000. Now note down here, by entering that argument, we are taking most frequent 20,000 words. So our processing will be easier. Now execute. This will load our dataset. Great. Now check xtrain. So these are the reviews in xtrain. These reviews are encoded in numbers. This is bag of words. In bag of words model, words are encoded in numbers, as you can see here. Now these reviews are varying. They don't have a fixed length. We will make all the reviews of a fixed length. To do that, we have to apply padding. Let us do it. Apply padding. Xtrain is equal to pad underscore sequences and in parentheses xtrain comma max length 100. Do same with xtest. Xtest is equal to pad underscore sequences in parentheses xtest comma max length 100. Let us understand this. To make all the reviews of a fixed length, we are applying padding. After applying padding, all the reviews will be of same length 100. Now suppose if a review has length less than 100, then zeros will be added, and if a review has length greater than 100, then it will be truncate. Now execute. Great. Now check the shape. Xtrain dot shape comma xtest dot shape. Execute. 25,100, 25,100. So there are 25,000 reviews in xtrain and xtest, and this is the length 100. That is 100 words. Let us revise. First we have done installation and setup. In installation and setup we have installed TensorFlow GPU version. Then imported the TensorFlow GPU version and we have checked the version. After that we have imported these three libraries, NumPy, Pandas and Matplotlib. Then we have done data pre-processing. To do data pre-processing, we have imported these two libraries. After that we have loaded the dataset. Now note down here, we are selecting only 20,000 most frequent words. After that we have applied padding, and at the end this is the shape. So this tutorial about installation setup and data pre-processing ends here. I will see you in the next one. Till then, happy learning. Hello and welcome to this tutorial. In previous tutorial we have completed installation setup and data pre-processing. In this tutorial we will build our model. Let us begin. First we have to define an object. Define an object. So here we are initializing our RNN network. Define object as model is equal to tf.keras.models.sequential. Execute. So we have defined this object of sequential class. Now we have to add embedding layer. Let us understand embedding layer. We use embedding layer to compress input feature space into smaller one. Let us understand this with the help of an example. Suppose we have 80,000 unique words in a text classification problem, and we have to pre-process the text and we have to create a term document matrix. Now suppose there are only 3 words in a sequence of sequence. Means in that 80,000 dimensional matrix there will be only 3 elements that corresponds to these 3 words. So this approach is memory intensive. To easier that process, we have to compress the input feature space into smaller one. And to do that, we add this layer, embedding layer. In simple words, we can say that embedding layer is a simple matrix multiplication layer that transforms words into their corresponding words embeddings. Or we can say that it turns positive integers into dense vectors of fixed size. Let us add this layer. Model.add tf.keras.layers embedding. Here we have to enter 3 parameters: input dimension, output dimension, and input shape. Enter input dimension is equal to 20,000. Then output dimension, we will enter 128. Then input shape. Let us check input shape. This one 100, nothing. Now note down here, embedding layer can be only used as first layer in model. So this is the first layer. And input dimension has to be equal to number of unique words. This one. Input dimension is equal to 20,000. In data pre-processing step, we have selected unique words is equal to 20,000. Scroll up. Here, number of words is equal to 20,000. These are the unique words. So we have successfully added embedding layer. Execute. Great. Now we will add LSTM layer. LSTM layer will be used to understand the relationship between different elements of sequence. In our case, LSTM layer will be used to understand the relationship between different words in reviews. Add this layer. Model.add tf.keras.layers.lstm. Here we will add only 2 parameters, units and activation function. Add units first. We will add number of units is equal to 128. For LSTM layer, units means number of cells. After that, add activation function. 10h. You can see here, by default activation function is equal to 10h. So we are using the same 10h. 10h is hyperbolic tangent activation function. Now execute. Great. Now add output layer. Model.add tf keras.layers.dense. Here we will enter only 2 parameters, units and activation function. Enter number of units is equal to 1 and activation function is equal to sigmoid. In this problem we will have binary output Hence, we are using units is equal to 1 and activation function is equal to sigmoid. Now execute. Great. So we have built our model successfully. Let us revise. First we have defined an object. After that we have added embedding layer. We have added embedding layer to compress the input feature space into smaller one. After that we have added LSTM layer. LSTM layer will help to understand the relationships between different words in reviews. And after that we have added output layer. Let us check the model summary. Great. So this is the sequential model and these are the layers. Embedding layer, LSTM layer and dense layer, and you can see other details here. Now after building the model we have to compile the model. Let us do it. Compile the model. To compile the model, type model dot compile. Here we will add 3 parameters: optimizer, loss function and matrix. Add optimizer first. Here we will add this optimizer, RMS prop. Now note down here, instead of Adam optimizer we are using RMS prop optimizer. For sequences this optimizer works better. Then add loss function, binary cross entropy. And at the end matrix, accuracy. In this problem we will have binary output, hence we are using loss function is equal to binary cross entropy and matrix is equal to accuracy. Now execute. Great. So we have successfully built our model, then we have checked summary and after that we have compiled the model. So this tutorial about building the model and compiling the model ends here. I will see you in the next one. Till then, happy learning. Hello and welcome to this tutorial. In previous tutorial we have built our model. In this tutorial we will train the model. Let us begin. To train the model, type model dot fit xtrain ytrain, then specify the batch size, that is 128. After that number of epochs I will specify 5, by default it is 1. Then specify validation data, xtest, ytest, and store this in a variable. History. That's it. Execute. The model training is started here. It will take around 8 to 10 minutes. So we have successfully trained our model here. Let us analyze. At the end, validation accuracy is equal to 83.9% and training accuracy is 94.44%. So the accuracy is not so bad. Let us make predictions. Define a variable ypred model.predict underscore classes and in parentheses x test. Execute. It will take little bit time. Great. Now print y prayed. Enter any index location. I will enter 10. Then print y test. Same index location 10. Execute. 1 1. The predicted value is 1 and actual value is also 1. Let us try for one more index. 15. Same here 15. Execute. Great. 0 0. Predicted value is 0 and actual value is also 0. As you know that 0 for negative review and 1 for positive review. So our prediction is negative review and actual value is also negative review. Let us draw confusion matrix. From sklearn dot matrix import confusion matrix comma accuracy score. Now define an object CM, object of this class, confusion matrix, and in parentheses y test comma y prayed, then print CM. Execute. So this is our confusion matrix. The diagonal values are the correct predicted values, these two, and other two values are wrong predicted values. Let us check the accuracy score. Define one more variable ACC underscore CM, that is for accuracy score, and in parentheses y test comma y prayed. That's it. And after that print accuracy score of this matrix, that is on the basis of matrix. Execute. 83.9. This is the accuracy score on test data. Same 83.9. Let us understand this. We have trained our model on 5 epochs. At the end, this is our validation accuracy and this is our training accuracy. Then we have made predictions. Here we have made individual predictions. Then we have drawn confusion matrix and accuracy score. Now we have to draw the learning curve. I will paste code here. Great. Let us understand this. Here we are defining a function, this one, learning underscore curve. In this function we have specified two arguments, history and epoch. In that function we are defining training versus validation accuracy and training versus validation loss. You can see the parameters accuracy, validation accuracy and accuracy. And in training versus validation loss, loss and validation loss. This one, validation loss and loss. And after these parameters, we have specified title, Y label, X label and legend. Same here. Now execute. Great. Let us call this function learning underscore curve. First parameter is history. Scroll up. We have defined history here. That means we have saved all the information about training the model in that variable history. Now scroll down. And second parameter as epoch 5. This is because we have trained our model on 5 epochs. Execute. Great. Here we have model accuracy and model loss. Let us analyze. First we will analyze model accuracy. Epoch versus accuracy. This is the training accuracy, blue one. And this is the validation accuracy, orange one. Now note down here, training accuracy is increasing, but the validation accuracy is not. Training accuracy is more than validation accuracy. That means the model is overfitted. This model has learned too much from the training data. Now scroll down. Model loss, epoch versus loss. This is the training loss, the blue one, and this is the validation loss, orange one. Same here. Training loss is decreasing continuously, but the validation loss is not decreasing after second epoch. So we can conclude that our model has learned too much from the training data. That is, our model is overfitted. To improve the model performance, you can add and change various parameters as well as various layers. But as of now, this is good. At the first attempt, we have accuracy is equal to 83.9%, which is pretty good. So this tutorial about IMDb review classification with RNN and LSTM ends here. I will see you in the next one. Till then, happy learning.